In the last video, we looked at a pretty simple example of a truth table. In this video, we're going to spend some time going through a more complex example. The keys to mastering truth tables are practice, which is why we're going to go through another example, and clear organization of your table. So the goal for this lesson, pretty straightforward. Just get more comfortable constructing truth tables. So the focus of this video will be constructing a truth table for this following sentence. If not A or not B, then not C. If you feel like you understand the basics of truth tables, you may want to try to construct it yourself and then check your answer at the end. But if you feel like you're not yet confident with how to construct the truth tables, this example will hopefully serve as another slightly more complex model for how you have to do so. Remember from the previous video that the first step in constructing a truth table is to list all the sentence letters and the complex sentence itself to get the columns of our table. So if we look through the sentence we're interested in, we see our three simple sentence letters. We've got A, B, and C. Those will be the first three columns of our table, and the last column is the complex sentence itself. The next step is to assign all the possible valuations to our simple sentences. So to get a different set of truth values in each row, we need 2 to the n rows according to our rule. And n is the number of simple sentence letters. That means we need 2 to the 3, or 8, total rows. Once we have the right number of rows, we need to fill in the possible valuations. We start with our first column, and you make half of the rows true and half of the rows false. So you need 4 trues and then 4 falses under sentence letter A. Then we move on to the next column, and we have the number of T's or F's in a row. It was 4, so now it should be 2. And we see under B, TT, FF, TT, FF. Then in the final column, we have the number of trues and falses in a row again. It was 2, now it will be 1, so we alternate true and false. The last simple sentence letter column will always be alternating true and false. The goal of following this pattern is that it makes sure every combination of assignments of true and false to the simple sentence letters appears in your table. So you get all of the possible combinations, and no 2 rows will assign the same truth values to all the simple sentences. At this point, we have the setup for a truth table done. Next, we have to determine the scope of the connectives in the complex statement, because that's what will allow us to start assigning truth values to the parts of that statement and building up to the truth value of the whole statement. We start by assigning truth values to the parts of the statement that take narrowest scope and work our way outward to determining the truth value under the main connective. Looking at this sentence, I see that the outermost parentheses take scope over the conditional. So that's my main connective, and I've marked it in red. I like color coordinating. Sometimes that helps for organization. It is not required. So we know what our main connective is. Now we need to figure out what connective takes next widest scope. So what is narrower scope than the main connective? Well, since the main connective is the conditional, we need to find what takes main scope in the antecedent and in the consequent. Those connectives are marked in orange. So they're the ones that take next widest scope. It's the disjunction and that third negation. There aren't any more connectives in the consequent, so we can ignore that for the moment. But there are negations for each of the disjuncts and the antecedent. Those are the connectives in this sentence that take narrowest scope. the ones marked in green. That's where we'll start to determine the truth value of the whole complex sentence on each valuation, given in the columns to the left. We rely on the characteristic truth tables for each connective to tell us how the sentence's truth value will be determined from the truth values of its parts. So for not A, we need to consider the characteristic truth table for negation. That tells us to take the truth value of the sentence A and reverse it. That gives us the truth value of the negated sentence. So in rows where the truth value of A is true, not A will be false. And in rows where the truth value of A is false, the truth value of not A will be true. So since we had 4 rows of true and then 4 rows of false under A, we see 4 rows of false under not A, and then 4 rows of true under not A. For clarity, make sure you align the truth value you get from applying the connective under that connective. So you can see this column is aligned under not A. We can run the same reasoning to get the truth value of not B. So if you look at B, you'll see that in each row, the truth value is flipped from true to false and false to true. And we put that under the negation of B. That takes care of all of our narrowest scope connectives. So we need to move now to the connective with next widest scope. That's our 2 orange connectives. And we'll start with the negation of the consequent. Again, negation tells you to swap the truth value, so alternating true-false will now turn into alternating false-true down the rows. At this point, we don't need to actually look at the truth values under our first 3 columns anymore, because the truth values of the disjunction and antecedent and the main connective will be determined by the truth values in the columns we've already determined. So the truth value of the disjunction will come from not A and not B, the 2 columns in green. And then the truth value of our main connective, the conditional, will come from the truth values under the disjunction and under that 3rd negation. So the truth value of the disjunction here is determined by the truth values of each of the disjuncts, which are the negations we've already determined in green. For the first row, for example, the disjuncts are both false, not A and not B. So the disjunction, that orange letter under the disjunction symbol, is going to be false. And then if we go down the column under the disjunction, remember that the characteristic truth table for disjunction says it's only false when both disjuncts are false. So you'll see that the disjunction is only false in the first 2 rows and true in the rest. Finally, we're ready to determine the truth value of the sentence as a whole. And we get that by looking for the truth value determined by the main connective, the conditional. And to get that truth value, we need to look at the antecedent and the consequent and use the characteristic truth table for the conditional. Remember that the conditional is only false when the antecedent is true and the consequent is false. So that's only in the 5th and 7th rows. At this point, our truth table is now done. The truth values in red under our main connective tell us the truth value of the complex sentence we are interested in on each possible valuation. And we've generated that truth value building up from the truth values of the parts and our characteristic truth tables that define our logical connectives. And that wraps up Lesson 3. So you should now know the characteristic truth tables for each logical connective, how to distinguish truth functional and non-truth functional connectives, and how to construct a truth table for a complex sentence of truth functional logic.